You can go ahead.
Okay.
Just turn it over to you anyways.
So the vast majority of what we've been working on is Heist. We did rename Heist to Heist. I will admit that I've got some folks in marketing that don't like the name Heist because it's just too awesome for them. I love the name
I think
Heist.
that's an indication that it's a good decision.
It kind of is. I mean, like, look at Soylent. That was a great name choice. Just make a meal replacement that makes people think that they're eating people, and it sticks in their mind, right? So we're making a piece of software that can be used for infrastructure security called Heist. Okay. So, I mean, another name change might happen, whatever, I don't care. At this point, I've named so many things and been criticized for so many names, it just kind of fits water off a duck's back at this point. Okay. The main things that we've been focusing on have been really around adding a couple of core features to Heist, as well as refining what our software delivery looks like. And so when I say software delivery, I mean being able to make portable versions of Salt. And as many of you are probably aware, and I've lighted on this a little earlier, making portable versions of Salt is its own little nightmare. Making portable versions of Python code is its own little nightmare. And so where we're at there, let me just give a brief summary. I have been able to successfully create a single Salt binary that is running on all major Linux distributions. So it is happily running on Debian 9 and 10, Ubuntu, CentOS 6 and 7, Arch, etc. Let me go over really briefly how that has been accomplished. I'm in the middle of building one right now. But I added enable optimizations to the Python compile, and so now it takes infinitely longer for this particular build, in which, yeah, for a production build, we should have enable optimizations. So let me do a little screen sharing here and talk a little bit about Salt Bin and what it is all about. So Salt Bin is an open source project. It's out there on the GitHub. And under SaltStack, and so you can check it out and build these to your heart's delight. It's surprisingly easy to use. All you need to do is run Python 3, and then the build.py file. Now, what the build.py file does is it takes a requirements file and it takes a exclude file and uses the version of Python that you are executing it with, bundles that version of Python into a single binary using PyInstaller. Now, PyInstaller has some challenges around bundling tools like Salt, particularly in that PyInstaller determines which Python libraries to add based on imports. And since Salt doesn't import things in that super standard Python way, because of the loader, we need to approach the problem a little differently. And so this build system, Salt Bin, goes through and creates a virtual environment. Inside of that virtual environment, it installs all the dependencies that you have, and then it builds the PyInstaller with the contents of said virtual environment, excluding a few things that we don't actually need. And Then the other thing that's nice about exclusion is that we can be more aggressive about specific aspects of the system that do get installed. And so, for instance, if we look at our exclude.txt, we're just making sure that PyCrypto isn't getting installed so that we can use something else for our crypto. Now, to make this thing run, obviously, on lots of different operating systems, I have taken the age-old tack of just building it inside of Red Hat 6 or CentOS 6, an old version of Red Hat. Now, with that said, it may make sense still for us to create these binaries on a per distribution basis. Now, a lot of my initial thinking was, hey, this is pretty slick. Why don't we just deliver salt in this way in general? The main challenge that I ran into there is startup time. If we, actually, let me go ahead and build one of these. So I just deleted the one that I had because I'm, well, yeah, whatever. Now, startup time. One of the challenges that we have is that these binaries effectively need to be able to unpack this entire Python environment. And so startup time can take a few seconds, and I'll demonstrate that once we get there. Let's see. Oh, yeah. So the other thing I wanted to talk about was being able to build this inside of a Docker container. Now, there are more elegant ways of doing this inside of Docker. I just haven't gotten there yet. But you can very easily just copy this build into a Docker container. And then there is a script called cent6 setup.sh, which goes in and compiles OpenSSL 1.1.1 and then compiles Python 3.75 on top of CentOS 6 so that you can have the latest, so that we can have the latest Python in here, and then builds against that Python. And then you're able to copy that outside. And so I've recently, like I was saying before, just added enable optimizations right here to the build of Python, forgetting that when you do that, that makes it so that you run the entire Python test suite twice, which takes about a half hour to run. So a production build in this manner takes a little longer, but in all honesty, we should probably have optimization since enabled on a build of Python that we're distributing. Okay. How's this coming? This is actually pretty quick. So, I mean, it's almost done. We've already gone through and scanned all of the hidden imports that we need to add into our binary. We've also gone through and created the virtual environment, and it's already building these final artifacts. There they are. And so we see that we have a nice little binary in here, and now that we've built it, we can do dist salt. And then with this salt binary comes all of the subsequent commands that are normally inside, that normally ship with salt. And so instead of saying salt dash minion or salt dash call, we can do salt space call. Then this binary redirects to execute the function which is initiated by salt call. And let's see, local. Oh, I need to, yeah. And so you'll notice that salt call is a little slower. Let me actually time this. Yeah. It's a little slower. But again, that's because it has to unpack everything. Now, for the purposes of heist, the main idea here is that this portable binary gets shipped to remote systems, and who cares if it takes the minion an extra few seconds, right, to start up in this situation, because we're cutting so much other time out of the overall bootstrap capability, okay? But this does, yeah, Garrett?
Sorry, just a quick question real quick. Does it, so every time you run it, it unpacks it?
Yeah. So every time you
Okay.
run it, it creates a temporary unpack inside of temp that it executes against, and then cleans itself up when it's done.
So yeah, to give you an idea, I just ran it the same command in a virtual environment with the regular salt, and it was 5.2 seconds real time.
Okay.
So if it's only 4 seconds added, you know, is that a big deal? I don't know. Maybe we could find ways to speed that up. I'm not sure about that, but
Yeah. And again, I mean, it's a big deal when you're running salt call. It's a big deal when you're running salt itself, and to execute commands. And even then, it's a questionable big deal. It's not a big deal when you're starting a minion or a master, right? It's not a big deal when you're starting a long running process. Which again, how Heist is working is shipping this thing over SSH to target systems and then starting up a minion. And the trade-off there, which is minions are all of a sudden infinitely easier to maintain because of this little binary. I think that trade-off is a huge win, especially in comparison to needing to maintain a litany of dependency packages, and especially when we're looking at Python version compatibility, especially in this case, since we're shipping Python, right?
yeah, in the context of Heist, I think this makes great sense.
Yeah.
So I mean, just following up with that, like in the context of Heist, how often do you think someone would be running a salt call? Probably never, right?
Yeah, theoretically never. In the context of Heist, this binary is sent over the wire. Heist starts up a minion process, and then we're done.
Yeah, I mean, even if you're just talking about like starting the minion when a box starts up, I mean, would anyone even notice? I mean, maybe they would, but I doubt they would notice that much.
Yeah.
If it's an extra 4 seconds on the minion startup, no, they probably wouldn't.
Yeah, and I completely agree there. But again, the cool thing is that we do have a portable binary, which I
That
have
is
to
very
admit,
cool.
I have lost a lot of sleep over making this stupid thing. And gone down so many rabbit holes. The guys at SUSE actually had a good suggestion to use app image. I really like app image from what it creates. Actually using app image is kind of a pain in the neck. It kind of assumes that you're already super deep inside of app image land, right? And so that it is a less than easy to use build system, although very, very powerful in nature. App image actually works the same way as PyInstaller, but app image unravels your complete app image into a directory in temp with added dependencies. This binary that we're looking at here is not static. I tried to make it static to solve that problem. But it turns out that when you try to force staticize a binary, there are, well, let's just say there are quite a few problems in making sure that your elf code lines up properly. And so I ended up abandoning that approach and just going back to, hey, if we link to libc in Cent6, we're going to be fine. That's held true. Um, let's see. We should probably actually. I'll ask Megan because she's been doing lots of this work. Megan, can you go over really quickly some of the additions we've made to Heist? I mean, in a nutshell, I feel like Heist is ready for people to start playing around with it, especially here in the next couple of days, as we're just polishing off a few more things, adding a little more error detection.
Yeah,
Yeah, go ahead, Megan.
I definitely can. I don't have like a demo set up or anything. I can try to run it, and hopefully the demo gods are one with me. Let me see here.
It doesn't happen very often.
Yeah.
They are capricious and angry gods.
And I'm in the middle of developing something else, so maybe
Yeah,
I'll just.
you don't need a demo it. Just talk to what you've added.
All right. I guess I can just show off the pull request, and we can talk through that. Let's see here. All right. Cool. So, so we renamed the project to Heist. Let's see. So initially there was just the YAML roster file, and we realized that Salt SSH by default is just passing into the renderer. So we renamed it to flat, just like it is in SSH, and it will also just pass into the ren project. And the default is gingy-YAML, but a user can now define what renderer they want to use.
Let me cover that really quickly, just to make sure anybody listening knows. Renderers, of course, is the system inside of Salt that takes Salt's SLS files and then renders them into data. And since Heist is built on top of POP, which is this new plugin system that allows us to compartmentalize complex systems, the Rend project is just another project that's there on GitHub that has begun to implement the render system from Salt and compartmentalize it in a standalone piece, making it much easier to use that render system in other projects. And so in this case, we're just saying, yeah, we just pipe everything to the render system, and the result there is that you just get the benefit of being able to render things in any POP project in a nice, smooth way. And again, as you can see, we've only implemented a couple of things, right? We've only implemented YAML, TOML, and Jinja. So it would, I mean, if there's anything that could use some help here, it is getting a few of those renderers ported over to the render system. Thanks, Megan. Sorry about the derailment.
Yep. No, you're good. Yeah, please feel free to comment. Another thing that was done is we added a couple of the rosters from Salt SSH, Cluster Shell, and the Scan roster. I think another big win would be there's a SSH config roster that I don't think would be too difficult to port over. And then some of the other rosters might be a bit more difficult to port over. But eventually we want to get those all over. And then we got this one. So currently the salt bin binary is being uploaded to PyPy. We're still debating on whether that's the right approach, whether we want to use PyPy or manage our own repo to store these artifacts. But what this PR is doing is it's allowing you to auto download the artifact if you don't already have it downloaded. I think that's all this one does. You can actually pass in a version if you want a specific version, and then if not, it'll actually just query PyPy and get the latest version from there. So that's what this one does. And then I just added tests for that. And then I should have a PR open today for being able to bootstrap non-tunneled masters. So essentially gives you the ability to, using Heist to start up the minion, but it's going to be talking with a different master. I'm almost got that done, but there is an issue I'm running into I still need to troubleshoot. So I think I think, oh, and then Tom, you added sudo, which is pretty important. So,
Oh, yeah. I need to add some tests for that. I mean, we've been really good about adding tests, but that one proved to be a bit more of a pain in the neck. Um,
yeah,
but yeah, we've got sudo in there so that you can define that a system is going to be using sudo to target a separate user. Right now, I've only got it so that you can target root, which is the majority case. So, but it also makes a lot of sense because obviously most systems that are exposing SSH don't allow direct root logins, and they shouldn't.
that's all I can think of. Another thing that I do want to improve on is I've mostly been writing a unit test case, so I do want to eventually add some more integration tests. So if anybody wants to help with that as well. Right now, there's only an integration test for the async SSH tunnels. So, but yeah, and then if you want to see any of the issues of what else we need to work on, you can obviously look at the issue list. So that's all I got.
Yeah. Excellent. One of those issues is Windows support. The hope is that we can hit Windows over SSH to begin with, now that Windows supports and ships with OpenSSH, which, man, watch it, Microsoft, it's been crazy. But building that single binary on Windows has proven to be a serious pain in the neck. As we've got it to build, but it just doesn't do anything. That's where we're at. We finally got it to actually build. Like, there's a binary now, and we run it, and nothing happens. So maybe it's just really slow and just a lot slower.
You said you got Mac though, right? Mac working?
Yeah, Mac works.
I haven't tested that one, but yeah, that's awesome.
Shouldn't be that slow, Tom. If you need someone to look at it, I can look at it.
I would probably appreciate that. I mean, I've been hacking through it. I mean, as you guys are well aware, I'm not a Windows expert, and I've been hacking through it and just kind of fixing things. And then I've asked Shane, hey, can you run this and tell me what the stack traces are? And then 4 hours later, after I figure out that stack trace, I say, can you do it again? So yeah, in all seriousness, if somebody can try and get this thing on Windows, like, it's really close. It builds. And I'm not entirely sure what I'm missing at this point because I keep running out of steam and having to do a lot of research on Windows. Yeah, but that's one of the last hurdles. That's really the last hurdles that we've got. What we've got left to make it so that we feel like we can get a 1.0 release out, something that we're not, that we're willing to show to the world and say, look, you're going to run into a few hiccups, but I mean, we can show that this works. And the bootstrap process, right? Standing everything up takes a little bit of time, just because we're copying these minions all over a network over SSH. But still, it's a significantly smaller amount of time than bootstrapping salt in a large environment. And once they're up, everything runs as fast as salt because it's just plain old salt. We're not looking at this through the lens of how salt SSH works, which also should mitigate a whole litany of problems we run into with salt SSH. And now the fact that this is working at this point and we're mostly just polishing edges, I feel really good about the prospect of potentially being able to, in some time in the future, potentially, deprecating salt SSH in favor of Heist. I think that this is frankly a much better approach to being able to deal with a agentful, agentless, or an ephemeral agent kind of approach than the knowingly extremely slow approach of salt SSH. And again, the fact that salt SSH means that we've got to re-implement a bunch of topological designs. Yeah. Okay. So any questions, comments, arguments, or rebuttals? Really, all we've got left are a few more bugs, some polishing, and writing documentation. All right. We can call it then. That is yet another status update on the progress of Heist. And let's see, tomorrow at the cloud meeting, I'm going to be there if anyone's interested. I've been roped into proposing a project that internally we've kind of jokingly called APID, which is the compartmentalization and separation of salt cloud and all of the salt state and all of the cloud states in salt, to solve a litany of problems we run into there. So that's tomorrow morning, and I might get that prototype. I might get some prototype of something working tonight. Don't bet on it. All right, until next time. Thanks everybody for coming.
See ya. Thanks, Tom.
Bye.